We have seen till now what is a generator, what is a iterator, what is an iterable. So what is the basic difference between these things? To just give a context, in Python, there were the basic data types. The basic data types means like int, so float, none, so boolean. Is there anything to optimize there? Nothing. So they were like single unit of values. But in data, we don't work directly with them, but we work with the data structures. I told the concept of data and data structures. Sand is the data. Data structure is the bucket or the bag that we use for carrying them. In the same fashion, in programming also, if you have data, if you want to carry them, we need to have something to hold them. So that's where we go with the data structures. So the common data structures we have is like list, tuple, set, and a dictionary in Python. So, but the problem here is that unlike other languages, we don't have a particular limit. So why we don't have a limit? Because our Python doesn't work directly on the machine. So there is no limit. Why it is happening is that the memory management is done in the backend. Once you give whatever the data may be, it will convert that to the C language and then it will execute onto the machine. So during that conversion, it will know how much memory to allocate and do it. But do you think that memory is like infinite? No. No matter what program does, the memory is finite. So over a period of time, if you have more memory consuming data structures, what will happen? Your entire program will crash. The reason being, in your system, there is something called as RAM. RAM is a finite thing. So 8 GB or 16 GB, which is very small. So within that RAM, multiple applications should run. Say your browser should run, Zoom should run, like, something else should run. But for everything, it should give some resource, right, within the RAM. That is called as a private heap. So everything will have its own private heap. So let's assume that if you have a RAM, which is 8 GB, within that, how much Python will get? Very small. Within that, if one program is running and in that few data structures are consuming very large data, then what will happen? So it will store the data over a period of time. If the limit exceeds, it crashes that Python application. So the process will be crashed. To avoid that, in Python 3, they came up with like optimizing strategies. That's where they came up with something called as iterators. Iterators means whenever you have these four data structures, if you pass to the iter built-in function, it will try to optimize that. Optimize means generally list has its own features, tuple has its own features, set has its own features, and dictionary. But if your purpose is like to work with large data, and if you want to just process one at a time, that's where iterators comes. Means no matter what data type they belong to, means list, tuple, or set or dictionary, but once you create an iterator, you can get only one value at a time. And once you got a value, you cannot get it back again. So that's why these are called as disposable objects. Disposable objects. And next thing, okay, for this it is okay. And then coming to the next one is functions. In functions also, there is no such limit, right? Generally, in every language, there is no limit for functions. You can write any logic. But sometimes in the process, it will take a lot of computational power, assume. Say like you are creating 1,000 prime numbers. But in reality, if you are using 2 or 3 only, what is the point of creating entire thing? Or else, even if you are using 1,000 prime numbers, if you are using one at a time, then why do you compute the entire 1,000 prime numbers at one shot? You can do like a on-demand computation, right? On-demand computation. So to make that, they came up with something called as generators. So for optimizing the data structures, iterables, we have iterators. So even the string is an iterable. For iterables to optimize, we have iterators. For functions to optimize, we have generators. What is the difference between a iterator and a so generator means what? Instead of a return, we will have something called as yield. Yield means like state suspension mechanism. Means whenever you are executing something, instead of executing all at one shot, it will execute one at a time. Each time when you call, it will go and give. And next time when you are making a call, instead of thinking to execute from the start, it will resume from the previous state where it passed. So that's the beauty of state suspension mechanism. This is what you need to remember. State suspension mechanism. So suspension and retrieval. Generally functions means if you call 10 times also, it will call from the starting till the occurrence of first return. Whereas for the yield generators, the moment it becomes a write yield, it becomes a generator. And the moment it goes to the yield, it will give the value. And subsequently, when you're asking a call, it will resume from the previous state. Okay, this is also fine about the generators. Then what is this concept of coroutines? So this is another thing called as coroutines. So generators are like a data producers, whereas coroutines are like a data generator, sorry, consumers. So why I am telling this logic? So it's very easy for you to digest. So basically, whenever in Python they create a new feature, they will give something called as a PIP, Python Enhancement Proposal. So similarly, when the coroutines were introduced, they created like one of the things. So if you want more, you can check with that correspondingly. You can check with this particular thing, PIP8. So PIP, so you will get to it. So it says about the coroutines via enhanced generators. Means they were generators only, but they were enhanced. If you want detail, you can go for the entire theory. But simply to explain how it works. You see, instead of using a typical yield, they will use some brace around the yield. What is this brace? What it is exactly doing? So till now, we know what is a function. Say like, I go with typical hello. If I say hello, and if I do a pass, then what will happen if I make hello? So hope we know that it is a typical function. So clear and Python 04. Okay. Okay. You can see that nothing happened. It's a function which was called. But rather than a print, if I say like print, say hello world. So you know that it will execute and it's a function which has a thing. So it will do it. So now do you call it as a function or a generator? Function. So instead of printing, if I do like a return hello world. So then what will happen if I execute? It will not give anything. So if you want the value, the only way that we can do is by getting the return value and retrieving the values. Say like, I am storing the return value and I'm asking. So instead of printing like this, I am doing like this, where I'm returning the value and storing it. Now we see that the return value is a string. So do you call it as a function or a generator? Function. So then how and when it will become a generator? So instead of a return, we do the same thing with an yield. Hello world. So the moment I do that, did you see it is saying it's a generator and you cannot execute directly. If you want to execute, we need to use the next built-in function. You remember? The next built-in function, if you use, then it becomes a generator. So as we have written the yield, it becomes a generator. And if I call now, so you can see that it will be a generator. See? So if you want to retrieve the values from a generator, so unlike a direct call, we should make a call and that value we need to assign to something and apply a next around the thing. Or we can apply a for loop. Either way, we can get the values from these optimized lazy loading objects. Then, sir, what is the difference between a generator and a coroutine? So coroutine means very simple. You do the same logic, whatever you do. Same hello world I will write, but observe the difference. This is what you noticed as a generator, but this is I am saying as a coroutine. What is the difference? In a generator, you have an yield and you have a value to yield. Whereas in a coroutine, I have a yield and a value to yield. Same thing only. But instead of leaving that aligned, I am assigning the return value of the means I am assigning that value which is coming from the yield to some variable, and I'm doing another yield. So what is the difference, sir? Will it make any difference? Yes, of course, it makes a difference. If I execute right now, did you see that? Is there any difference between these two? In terms of execution, if I say, if I do like this also, it is saying it's a generator, and the next of it is giving hello world. Like this also, it is saying generator, and next of it is saying hello world. But it is never saying like it is a coroutine, right? That's the difference. I told coroutine is also generator of enhanced way. So how we do? Let me make a slight modification to this. So why you are doing a hello world here? Let me take a small modification and do like this, where I do a yield, but I don't assign any value to it after the yield. So, but I am assigning to a variable and I am yielding again the variable. So if you don't assign anything, by default, it will assign the none. Did you see? It is the same coroutine, but with like this. Now, sir, if I do a slight change here by adding a one more print and doing it. So this time what I'm doing, I'm yielding a number. So, and I'm returning. So you see here, so in the second time, instead of just a yield, I'm saying like yield passed value so and so. So whatever the value, if you pass, it will take here, that value it is assigning, and that value it is yielding further. So like a two extra step, right? Instead of a single yield, you will have two yields. Now, what is the point of this kind of value? So how different is from a generator? So till now we have seen how to just create and use it. So this typical making the first call is called as a priming. So if you want to use like a coroutine, first time we need to do like the priming. Priming means we need to make a next call. So you know, right, ordinary function call, when you make a call, it will give you the execution. But for a generator, the execution actually starts the moment you ask for the next, or like using a for loop for the first time. So this is called as priming. Once priming is done, so then what? When you do a next, what is the first value that we have it? 1, 2, 3, 1, 2, 3. It will give it. So if I execute it, it will do like this, right? But subsequently, if I ask, hey, give me again the value. Is there another value here in the next? So when you ask, it is saying what? Hey, so passed value is so and so. Passed value is none, it is saying. Did you observe? Passed value is none. Say, I am doing the same thing for some number of times. Did you see what will happen? So initially when you do a next, what are the first value you got? Next, subsequently you do a next, you got the second value. But after that, is there any other yields? No. So then what happened? It throwed an error for others. So that is what we understood. For two things only, two times only it worked. Now, what will happen next? Till now, we don't know how to do. It is like typical thing. So I told like, it will fail if I do further. So we understood that it won't execute further. It will throw an error. So it is a stop iteration exception. I wrote the same. Now the actual magic of, coroutines comes. Till now, we know that for the result, which is the thing, I cannot do anything else. But for the first time, we can do like send. I will send a value. So if I say like, world, if I do like send of world, it will execute. So what it is doing is like, hey, you already did the next. Means there is no more yield. So it already executed down. So it cannot execute further. But if I comment it one, means if I execute only for the first time, then it will not go to the second one. So then it is executing. What is this concept of send, sir? I will tell you. If I do the send right now, see, I use the only the first yield. I am not making two times. I'm making, this is called as priming. For the first time only I should do, and subsequently I need to do. As it is a print statement, I can do better. Say result dot send of world. If I pass whatever the yield value is there, instead of that, this world will go. That's why you can see that passed value is world. Say like now, I am doing like one more thing. So instead of world, say like, say go line. So if you see now, it is throwing an error. Means because there are only two things. First time we are able to use by priming, which is needed. Subsequently, you can do only one time. After that, if you are using any further, it will throw a stop iteration exception. Hope you understood. Because there is only two things. First time we need to do mandatorily. Subsequently, if you ask, it will throw an error. If you want to handle also, we can do stop iteration exception. But you understood the basic concept now. Let's go with like more advanced things that slowly you will understand. Let me go with one more small example. Say like the coroutines. In the coroutines, I told like we will send the values. Let me take this example. Say this time I have done like a yield, the default string. First time initially when you do a priming, it will be helping. Subsequently, I wrote two yields. Either you can do like a next to get the values, but coroutine means what? For sending the values. If you do dot send, so you first time it will take to this one value, next time it will go to the next one value. So next time it will go this and you can get it. So what is the step by step process? Whenever you are creating a coroutine, the first step is same like your generator. Means I create like a call, I will assign to something and I will ask the type, it says generator, fine. Now I told if you want to use a coroutine, first we need to do the priming. Means calling the next for the first time is called as priming. The moment you did a next, what is the first value for the yield? It has default string. So that's why you got a default string. Subsequently, if I send some values to it, how many values I can send? 1, 2, and 3. So you see what will happen. If I send 3 values, so for the first, it is not taking any, it is taking your value, which are is going. So from the yield, first yield, I am returning to this and I'm doing it. Observe. So I did like first or second, I will get the values. Did you see? No matter what you pass, you are getting the same result. So clear Python be so and so. Did you see? For the first also you are getting the first value only. When you pass second also you are getting the first value only. Why? Because the previous value only it is written. For the first time, whatever value you pass, that first value will be replaced by this one. So, and the same thing is used. And for the third time, did you see you are passing another variable? I'm not doing like a yield value, but I'm saying like a yield new string. So though I passed something else, I got this one. Now, what is the final thing I have? So if I do like, 4, will it work? So if I say like, fourth, so am I supposed to get the fourth? So I got the fourth also. Why I got the fourth? Because like this is the last value we have. So that's why you got the fourth. Then can I do like fifth now? IFTH. If I do like a fifth, will it work? If you see, it throws an error, which is stop iteration exception. Means, so once it don't have that yields to take, it cannot do it. So, and also one more point is like, once your work is done, we can close our coroutine. It's like, someone is ready to take a catch from your ball. So whenever you're throwing a ball, someone should be there to take, right? So like that, it will also be waiting for some time. So after that, if you do the close, it cannot accept further, though you have yields. So this is what we need to learn. And subsequently, let me take one more example. Then slowly you will understand better. Because coroutines are the heart for the asynchronous communication. Nowadays, non-blocking execution is very famous. So next you will subsequently learn that in future. So for that it will be useful. Now the point is you are slowly understanding the coroutines. But the problem is that every time when you are passing the values, there should be enough yields to consume whatever you're passing, right? In generators, you are generating the values. In coroutines, it is consuming the values. So if I take this example, I am doing like a while true. Means like what? Infinite amount of times it will take. For the first time, it will give 1, 2, 3, 4. And subsequently, whatever the value you pass, it will go to the yield and it will be received and you will get that value. So now, if I take the example, if I take like a small example, if I say coroutine. So if I take a coroutine and the next step would be the priming. So I do the priming and subsequently I need to pass the values. So here, as I don't have any limit, I can pass any number of things, right? So if I pass right now, clear and pass C so and so. Did you see every time I'm taking the yield and the received value only I'm printing, right? You see now it will execute. Whatsoever the value pass, it is executing. And not just think, let's say I'm making like a for loop and I'm passing the values in a for loop. So if execute, see here, what will happen? I am passing in a loop of 9, 0 through 8. I'm getting all the values. What are the values I passed I'm getting? And similarly, after my work is done, I can close that coroutine. So this is priming of the coroutine, creating a generator, priming the coroutine, and like closing the coroutine. And between that, we are sending. So we know that it is infinite amount of times because of while loop and without any condition. But after closing, if you try to execute something, it will not allow. It will say that, coroutine is closed, can't send any more values. So you get like stop iteration exception. So let me give like one more example. I think a more real world example. I would say like, C2, say like, so uh, person details .py. Let me take a very humanoid example. So for you to understand, say like person details. So assume that, it will take the values and it will execute. Say while true, it should take the values from us, the users, and you do. Maybe like, can I take it as an assignment for you? So you take like the simple. So my intention is like, you pass the details. You need to pass the name, age, salary. So if you pass these three, it should give like in a particular format. So means you need to write some logic and subsequently I will make a print statement. In that print statement, I do like a F string. So I can do like a, so triple quote content means we can go to multiple lines. So that's what we know. So within that we want to display. So name would be the name given. So age will be the age given. Salary will be the salary given. So hope you can try that. So you need to do some logic such that it will take the values. So till now, I'm taking yield a single value, right? So think about yielding like multiple values. So how to take that? I think that would be a good example. So for it, can you do that? Can you do all do that? So where you need to work on this one? Yes.
Yes.
Yeah. Give a try. So how to do that? It's a simple logic, how we need to execute it. So I can say like default. So, but like subsequently you can pass on it, how to use it. And then if I go with the next example, um, in the coroutines, say I want to have some kind of a limit. I can take that example. Say if I go coroutines with some kind of limit, in that limit, what we do, if you want it to be executing for a finite amount of time instead of infinite amount of times. Earlier what? we did for the infinite amount of time. For that, we did a while loop, while range. The same thing if you want to do with a finite amount of time. So the best part is like, so using the D. So finite coroutines.py. So if I do like this, what I am doing, instead of that, I am passing some limit. In a for loop I am doing. That's the only difference. You can, if you want, you can create coroutines like this. And also the most important thing, so chaining the coroutines. Hope you remember on the other day I explained how to chain multiple generators. So that is called a generator pipeline. So instead of executing all at one shot, we can do in a chain of actions. In the same fashion here also, we can do chain of coroutines. Say we have a producer which is taking like two things. So the sentence and the next coroutine. So it is taking like and doing a send. And similarly, you have a pattern filter. It is taking and sending the value. Similarly, you have the third one, which is doing like this. So what we are doing, we are chaining the first value. See, every time priming is the most important thing. A coroutine means generator you create called and you primed it. So this generator you called and primed it because this generator is passing input to another. And the third one you made a call and you are making. So this producer is a typical function. So it is using a send and like close. So that's why reason it is not primed. So this is how like some examples of using the coroutines for different things. Next, so why I explained this in length? Because subsequently we will learn something called as async IO. Async IO, let me explain the concept. Then subsequently we will see in a different module. So there is a module called as async IO. So which was introduced way around in 3.6 around for that. If I work on it, so if I ask like, hey, what is the DAR? Print of DAR of async IO. You can notice that clear and Python. So F so and so. Did you see the list of attributes it has? It's a big thing. So it's not just a small thing. So we can do a lot of things. But generally, how the async works. To understand that, let me give a very simple example. Traditionally, in all the languages, whichever you learned till now, like a Java, C++, everything, if they assume that there are three statements, each statement is executing for 5 seconds. So after the first statement, it will go to the second statement. So after the second statement, it will go to the third statement. So if each statement is taking 5 seconds, totally it will say 15 seconds. Whereas in a non-blocking execution, if I have first statement, second statement, and third statement, so where like each one is taking 5 seconds, then what happens? It will just give you a hit and it will not wait for it to complete. It will go to the next line. Sir, if we need to create a logic in such a way that first one has no dependency on second thing. If there is a dependency, then this kind of code will not work. Let's assume that we are making a calls to three database queries, three tables, and getting the results, and we are combining. In those cases, each one is not dependent on another. So, but the end result is dependent. So each one can execute in the same 5 seconds. So totally execution will happen in just 5 seconds instead of 15 seconds. So this is called as a non-blocking execution. This non-blocking execution can be done in a different ways. So subsequently, I will show you how to run. But typically, in the old style, when the initial Python 3.6 and others came, so we used to use async IO like this, like a decorator, and the ordinary function will have this yield and we work with it. So within that, if you want to sleep also, we cannot use time.sleep. We should do async IO.sleep. So like that, we used to work in the older way. But that was changed way back in 3.7 and 8. So where they introduced the concept of async and await keywords. So before a function, if you define async, it becomes a asynchronous function. So if you make like an await, so what are the execution is there, it will wait for that. Means here I told that three statements are executing three different things, but we need to consolidate that final result. So we should wait there. So that is the concept of await. Within the logic, whenever you want to await, we can do. But these functions cannot be called directly because Python, they cannot change the architecture completely. So they did like async IO dot run of that given function. And also, so we can work like that. So then next we will learn future about the uh, async IO. There we will see more about these things. But next you will see and focus more on the modules. So basically, modules means like in Python, we have different kinds of modules. Module is like a library. So to be precise to say, whenever you are working on anything, so the simplest thing to learn is about the Python module. So say like if I need to work on math module, um, so the simplest way for you to understand is I took like the text file. So, but it's not a text file. It is like IPYNB, right? IPython notebook. So IPython notebook, I have already created, just I'm trying to use. So, so to save some time, so import math module. If I do the dir, you can see the list of all the attributes it has. And you know that dir will give the list of attributes. But if you do like the help, you will get the entire documentation. So what is this module doing? So what are the functions and what are the variables? For this, there were it's a lot truncated. But if you see in the text editor, you can see the values further also. So and if I go further in terms of the constants first, within the math module, they've added the basic constants in mathematics, like pi value, exponent value. So whatever we do, and like so we have infinity. Infinite means like so infinite value. Whenever you're doing logic, we want to, if you want to get the minimum value, whenever you're doing some logic, then we need to have first check like it should be maximum, and we need to compare, right? So for that infinite values or negative infinite also same way, and not a number. NaN means not a number, and tau it is another mathematical constant like pi. Now coming to the functions, so there were certain logics we can do without this math module also. With the advent of math module, things became slightly better. So I tried to group the things as much as possible to help us. The first set of functions are about the seal. Seal means you can imagine the above means up. So floor means down, right? So low, truncate, and integer. These are four sets. Firstly, if you see the first set, 9.7. So it is a decimal. So after 9 it is there. So 9.5 is there. 9.1 is there. 9.00001 is there. And seal of 9 is there. Minus 9.1 is there. So except this one, all these things are positive. And everything is above the 9. So for that given value, what is the next integer? 10. So for any value, if it is not an absolute value, like 9, 10, 11, these are absolute values. If we say 9.5, 9.6, these are not absolute. So absolute is a wrong word. So it is not an integer value. So, okay. So whichever is the next integer, you will get it. After 9.7, which is the integer? 10. So that's why in these cases you got 10. So the first three cases you got 10. But in this case, you got only 9. The reason being, so in Python, a post decimal by default it will retain only 16 digits. So it will do only 6 digits, sorry, 6 digits. If you want to retain a very large small values, we should go for a module called as decimal. So by default, when you give a value like this, it will first round off and go only till 6 digits. It will remove the things remaining. It's not just removing, but round off to the nearest. So that's the reason as it becomes 9.0, so absolutely you got 9 only. Similarly, if you do 9, then also you got 9. But if you see minus 9.1, this is very interesting. Minus 9.1 means, in negative reverse will happen. So 10 is lesser and 9 is greater. So that's why you get like minus 9. In the same thing, reverse will happen for a floor. For 9.7, which is the smallest integer? 9. You got 9. So for 9.5, which is smallest? 9. So 9.1, which is smallest? 9. So this I told the story. And this is minus 9.1. You get like minus 10. Means whichever is smaller, you get it. And coming to the case of truncate, it doesn't matter what is there after it. You can just think like after dot, it will remove everything. It's like, so merciless cutting. So you will get 9, 9, 9, 9, 9, 9. Even it is minus 9.1 also, you get 9 only, minus 9. Sign will be retained. So this truncate action will be the same as what we do in a int built-in function. Whatever you pass to the int built-in function, so it will convert like that. But if you give like a string as a floating point value as a string, then it will throw an error. That is different. But if you give like a floating point value, it will do mercilessly. Then what is the action of round, sir? Means for any after the integer, if any value between 0 to 0.5, it will give to the previous value. From 0.5 onwards, it will go to the next value. If you see 9.7 greater than 0.5, so it is 10. 9.5, that is also greater, right? So till 0.5, it will be previous. From 0.5 onwards, it is the next. So if I say 9.4, then you get 9. So 9 point so and so. So like that you get it. Even 9 minus 9.1 also, you get 9 only. So like that it works. So, and if you go for the round by default will be giving a floating, so integer, okay? But if you give after round, if you give some decimal, it will give a floating point result. No matter if you give 0 also. But if you give 1, 2, 3, so and so, you will get those many decimals. Till that much it will retain. Similarly, if you can try this others with others, like there is something like a next after. It will return the next floating point value after this value. Means for you gave 2 and a 5. So after x towards y, means from 2 towards 5, what is the next integer? So it will give a next floating point value. So means it gave these many 0 values and it gave it. If I say 2 minus 0.5 means it is giving 16 decimals. After that, it's trying to reduce the value. So like that, next after, like similarly power operation. But the difference between the basic power operation is like, so if both are not floating point values, you by default get an integer. But in math function, the power operation will give floating point value no matter if it is. So it will take only 2 values. But our built-in power function, so we'll take 3 arguments and do the reminder operation with the third value. But that kind of thing cannot be done with power operation. And similarly, reminder operation, we can do the same thing. Similarly, the fmod. Fmod is another thing. Fmod and like same like mod, but like floating point value. And absolute. So absolute means even if you get negative also, you should get positive. F absolute means like negative also positive you will get. Even if it is integer also, you'll get floating point value. So F absolute, every time it will give float. Similarly, copy sign. This is very interesting. So you want the first value with the sign of the second value. So you got the first value, which is a 9, with the sign of second value, which is 2, which is positive. So that's why we got 9. Similarly, like that you get for everything. Copy the sign. And we can do the factorial also. So, and like sum, we have like F sum. Same sum, but in a floating point value. Similarly, the GCD, greatest common divisor between two things, and LCM, least common multiplier, and like square root we can do, and like cube root, we can do the cube root, and like mod F, floating point mod. So the F mod and mod F, you can check the difference, how different they are. And we can do the exponential operations, logarithm. So in logarithm also log base 10, log pi. So different things. And also it supports trigonometric functions. We can convert from radians to degrees, degrees to radians, sine, cosine. So, tangents, a cosine, all these things we can